In the past century, our understanding of the universe has grown exponentially, revealing astonishing secrets of the cosmos. We have created cutting-edge particle colliders to delve into the subatomic realm, constructed instruments capable of detecting gravitational waves from far-reaching corners of the cosmos, and even achieved the remarkable feat of capturing an image of a black hole. These impressive engineering accomplishments are the direct results of predictions made by general relativity and quantum field theory. These two highly successful theories have given us a deep understanding of our universe, enabling us to explore and explain phenomena ranging from star formation to black holes to the universe's birth. Along with the Standard Model, these two theories can explain everything we see in the night sky. However, unseen by us, there is another universe lurking in the dark, a universe filled with mysterious dark matter and dark energy, which are crucial to our modern understanding of cosmology. General relativity, a fundamental theory in physics developed by Albert Einstein, describes how matter and energy bend the fabric of space-time, giving rise to the force of gravity. This theory offers a deep understanding of how gravity behaves on cosmic scales and its impact on the paths of planets, stars, and galaxies. It explains why objects with mass attract one another and how the geometry of space-time is affected by massive objects such as black holes and the expanding universe. On the other hand, quantum field theory describes the behavior of subatomic particles, the building blocks of matter, and the fundamental forces that govern their interactions. It allows us to understand the world of particles and their interactions on the smallest scales, providing insights into the intricate fabric of the universe. The Big Bang Theory is the most widely accepted explanation for the origin and evolution of the universe. It suggests that the universe began around 13.8 billion years ago from an extremely hot, infinitely dense singularity that rapidly expanded. As the universe continued to grow, it became less dense and cooler over time, ultimately leading to the emergence of galaxies, stars, and planets. There are multiple lines of evidence supporting the Big Bang Theory. One piece of proof is the observed expansion of the universe, where galaxies are moving away from each other at high velocities. Through telescopic observations and applying the laws of physics and general relativity, scientists can trace this expansion back in time, revealing that the universe was once much smaller and denser. Ultimately, this extrapolation points to the singularity that marked the origin of the Big Bang. Another piece of evidence is the cosmic microwave background, a pervasive radiation remnant from the early hot and dense state of the universe. Using the cosmic microwave background and the recession velocities of the universe, scientists are confident that they can trace back the universe's evolution to t equals 1 times 10 to the negative 43 seconds. This achievement is truly remarkable and demonstrates the impressive capabilities of the human mind. What lies in the dark? Scientists are currently facing a major challenge in understanding the composition of the universe. They have determined that only 5% of the universe is made up of baryonic matter, which includes stars, planets, and humans. The remaining 95% is composed of 27% dark matter and 68% dark energy. The term dark can be misleading, as our understanding of these substances is limited and they cannot be directly detected. We can only infer their existence based on their effects on the universe. Dark matter is a mysterious substance that does not interact with electromagnetic forces, making it invisible as it neither absorbs nor emits light. Instead, scientists detect its presence through indirect methods such as gravitational lensing and by observing the unexpected velocities of spiral galaxies. Weakly interacting massive particles, or WIMPs and axions, are two primary candidates for dark matter. Despite significant research efforts, scientists have not yet detected these elusive particles. Alternatively, Modified Newtonian dynamics, or MOND, is a theory that proposes gravity behaves differently when it is very weak, such as at the edges of galaxies. Although MOND is capable of explaining several observations in galaxy dynamics, it struggles to explain relativistic effects such as gravitational lensing and gravitational waves. In contrast, dark energy's primary effect is to drive the accelerating expansion of the universe. The nature of dark energy is more hypothetical than that of dark matter. After decades of extensive research, we still lack substantial knowledge about dark matter and dark energy. The fact that we are uncertain about their composition is significant, particularly because the dark stuff constitutes 95% of our universe. It seems almost paradoxical that while we can predict conditions a fraction of a second after the Big Bang, yet we remain completely in the dark about the composition of most of our universe, no pun intended. How do we reconcile this enormous gap in our understanding of the universe? Could we have a cognitive bias that causes us to overestimate our knowledge and abilities? Not knowing the scope of your own ignorance is part of the human condition. The problem with it is we see it in other people, and we don't see it in ourselves. The first rule of the Dunning-Kruger Club is, you don't know you're a member of the Dunning-Kruger Club. David Dunning. How do we evaluate our progress in understanding the universe? Do we measure our achievements and claim that our work is almost complete? Or do we acknowledge that not knowing what 95% of the universe is made of represents a significant shortfall in our knowledge? Perhaps to truly comprehend our universe, we need to shift our perspective. Instead of focusing on the light, we should embrace the darkness and break free from our baryonic bias. The universe does not owe us its secrets. Just as we once believed in a geocentric universe where the Earth is at the center and the planets and stars revolve around it. Perhaps our intuition has failed us again, and we live in a universe dominated by dark matter and dark energy. Thank you for watching Exploring the Dark Universe, unveiling the mysteries of dark matter and dark energy. Special thanks to our contributors and supporters.